All right, so far with limits, we have learned about graphs and reading the limit from the graph. We've learned about creating tables to find limits. And today we're going to look at finding limits algebraically. First thing you try every time is direct substitution. If you can do direct substitution and get a valid answer, you're great, everything is fine. If that doesn't work, we want to see if one of these three things works. So we want to see if we can rationalize and reduce, if we can factor and reduce, or if we can get a common denominator and reduce. Okay, so any of those three options. So we're going to try some to start with. If I have the limit as x goes to 0 of x squared minus 2x plus 4. Okay, x squared minus 2x plus 4. So my first strategy is to try direct substitution. So I'm going to use the 0, and I'm going to put it in wherever there's an x. So I have the limit as x goes to 0 of 0 squared minus 2 times 0 plus 4 gives me 4. So that's a valid answer. So we don't have to worry about doing anything else. In a second, you're going to see what's not a valid answer. But for right now, we're good. Okay, so let's try another one. We have the limit as x goes to, as x goes to 2 of e to the x squared minus 2x squared. I'm sorry, x squared minus 4. I had to make it work in my head. All right, so what do we have? Direct substitution first. So this is e to the power of x squared minus 4. That whole thing is in the exponent. So we're going to use direct substitution. So 2 squared is 4. So I get e to the 0 power. What is any number to the 0 power? Any number to the 0 power is 1. So let's try another one. We have the limit as x approaches negative 1 of negative x. So I'm going to use direct substitution. So negative 1 is positive 1. Okay, so we've got the, I shouldn't have drawn a line there. I don't know if that bothers you or not, but it bothers me. All right, so what we have now is we've tried direct substitution and it works every time. The next thing that we're going to try is direct substitution where it doesn't work. So I'm going to go to x to 3. And I've got x squared minus 9 over x minus 3. Okay, so what do we try first? We try direct substitution, which is going to give us 3 squared minus 9 over 3 minus 3, which gives us 0 over 0. So that's an issue. That is an issue that we have to solve. So going back to what we had a while ago, what are our options? Hang on, I got to find it. Our options, if direct substitution doesn't work, we're going to try factoring and reducing, or rationalizing, or a common denominator and reduce. So let's flip on back here. Of those options, which one makes sense to try first? Well, this is factorable, so let's try factoring. So I have the limit as x approaches 3 of x plus 3 x minus 3 all over x minus 3. So now I can reduce. What reduces? The x minus 3's reduce. So that leaves me with x plus 3. So I can use direct substitution now and get 3 plus 3, which is 6. We have the limit as x approaches negative 5 of x plus 5 over x squared plus 5x. All right, so what are we going to do? We try direct substitution first. So negative 5 plus 5 is 0. So right now you know something. This is either an answer of 0 if it is 0 over any other number, or it is indeterminate if it's 0 over 0. So I need to figure that out. So I'm going to substitute in the denominator. So that's negative 5 times negative 5 is 25. Plus 5 times negative 5 is negative 25. So 25 plus negative 25 is 0. So I have an indeterminate form again. So what do we learn? We're going to try factoring. So I have the limit as x approaches negative 5 of x plus 5. And I'm going to pull out an x from the denominator. I said I'm going to pull out an x. All right, so I get x plus 5. So my x plus 5's reduced. Be very careful. That doesn't leave you with x. That leaves you with 1 over x. And now I can use direct substitution again, and I get negative 1/5. So I have the limit as x approaches 9 of x minus 9 over the square root of x minus 3. And I have to shut my study door. Hang on. The dogs are fixing to bark. All right, so we have this issue here where if I substitute in a 9, I get 9 minus 9 is 0. The square root of 9 is 3. So 3 minus 3 is 0. So I got an indeterminate form again. So this one we're going to rationalize. What we've done so far is direct substitution. When that didn't work, we tried factoring. So now I see this square root right here, and that tells me to rationalize. So I'm going to multiply by the conjugate. So the limit as x approaches 9 of x minus 9 and the square root of x minus 3 on the denominator. Okay, what I'm going to multiply by is called the conjugate. It means I'm going to take this and rewrite it, but change the sign in the middle. So that gives me the square root of x plus 3 on the top and on the bottom. So really, I'm just multiplying by 1, because any number divided by itself is 1. So I'm changing what this looks like. I'm not changing what it is. Okay? So since the whole point of this is that I'm trying to reduce, I am not going to FOIL out my numerator. It'll make life worse. So I have the limit as x approaches 9 of x minus 9 times the square root of x plus 3. And then let's see what happens with our denominator. If I FOIL this, the square root of x times the square root of x is the square root of x squared, which is going to be x. Okay? Then I have plus 3 root x. Then I have minus 3 root x. And then I have minus 9. So what's the cool stuff that happens now is my O and my I of FOIL reduce out. So this and this are gone. So that leaves me with the limit as x approaches 9 of x minus 9 times the square root of x plus 3. And that's going to be over x minus 9. So what happens now? This and this reduce. So I'm left with the square root of x plus 3. When we try direct substitution at this point, we have the square root of 9 plus 3, which gives me 3 plus 3, which gives me 6. Okay? So let's try another one. Sorry, that was my phone. All right, I have the limit as x approaches 4 from the left. Okay. There, that's better. All right, so I have 2x squared plus 16x plus 30. And then I have x squared minus 6x plus 8. So the first thing I do is direct substitution. So we're going to try direct substitution first. Even though I'm coming at 4 from the left, I'm still going to just evaluate at 4 and see what happens. So I have 2 times 4 squared plus 16 times 4, and then plus 30, which gives me 126 for my numerator. And then I've got 4 squared minus 6 times 4 plus 8. And that gives me a 0 for my denominator. So now we've learned something else. If I had a 0 for the numerator and any other number for the denominator, my answer would be 0. Okay? If I have 0 over 0, it's indeterminate and I've got to do some work. So this is the first time that we've seen a number over 0. At least in this section, this module. This is the first time we've seen it. So what I'm going to do is say my answer is either positive infinity or it's negative infinity. I've just got to figure out which one it is. So my answer is either positive infinity or it's negative infinity. I've got to figure out which one it is. So that's when I have any number over 0. So what's a number that's close to 4, but a little bit to the left? So a number that's close to 4, but a little bit to the left is going to be 3.9. You could use 3.99, you could use 3.999, but you want to get pretty stinking close to 4. So I'm not going to use just 3. I'm going to get really close to 4. All right, so that gives me, when I substitute this in, all I'm looking for is the sign that pops out. I want to know if it's positive or negative, and that's going to tell me if I'm going to choose positive or negative infinity. So I've got 2 times 3.9 squared plus 16 times 3.9, and then plus 30. So I get 122.82 for my numerator. My denominator is going to be 3.9 squared minus 6 times 3.9 plus 8 and I get a negative 646.421. So I got a negative answer. So which infinity is my answer? The infinity that's my answer is a negative infinity because I got a negative answer when I plugged in a 3.9. So let's try it from the other direction. I have the limit as x approaches 4 from the right of this same function So again, when I do direct substitution, I'm going to get 126 over 0. We've already done that. But now I just need to know which infinity it is. Is it positive infinity or is it negative infinity? So what's a number that's a little bit to the right of 4, but that's still pretty close to 4? So we're going to try 4.1. And again, we're just looking for the sign that pops out. If it's positive, my answer is positive infinity. If it's negative, my answer is negative infinity. So we're going to try 4.1. You can try 4.01. You can try 4.001. But you want to be really close to 4 from the right. Okay, so we're trying 4.1. So I have 2 times 4.1 squared plus 16 times 4.1 plus 30, and I get 129.22. I'm going to divide that by 4.1 squared minus 6 times 4.1 plus 8, and that's going to give me a positive 615. So what did we learn? We learned that we plugged in a number, we subbed in a number that's really close to 4 from the right, and we got a positive answer. So the answer to this one is positive infinity. Now, what happens if I want the two-sided limit of this function? Does negative infinity equal positive infinity? In other words, coming from the left equals coming from the right. No, it does not. So my limit as a whole does not exist, or the two-sided limit does not exist. All right, I'm going to take a break on this one and make a second video.